The cosmos is mostly emptiness. It's a profound, stunning emptiness. And these vast empty regions, the cosmic voids, they're essential. They're absolutely essential to the universe's design. The night sky isn't just a scattering of stars. It's a structured masterpiece, and it's defined by what isn't there. The gaps might be more important than the glittering objects. A region of space with almost nothing in it that can tell us about dark energy. This is how nothingness builds everything. It builds galaxies. It builds the possibility of our own existence. Empty space, it makes you reconsider everything. The universe has a hidden structure. You look past the stars and you see a pattern. It's not chaos. It's this delicate, vast thing, the cosmic web. Imagine the most intricate lace stretched across billions of light years. The bright threads are filaments, rivers of galaxies, and the huge, dark spaces between those threads. Those are the voids. That's the real skeleton, a framework built from absence as much as presence. Those empty regions aren't accidents. They're the foundational negative space. The carved-out chambers that give the web its three-dimensional form. Without the voids, the cosmic web wouldn't exist. It would just be a formless fog. The emptiness actually shapes the glittering structure we see. It's like a sponge. The solid part is the clusters and filaments. The holes are the voids. Or soap bubbles, the thin walls are the galaxy filaments, and the vast space inside each bubble is the void. This whole structure is an echo of the universe's beginning. After the Big Bang, there were tiny ripples in density, quantum fluctuations. The rapid expansion stretched them across the cosmos. Dark matter, that invisible scaffolding, began to clump within those ripples, pulled by its own gravity. Ordinary matter, the stuff of stars and planets, got pulled into those growing dark matter wells. Then gravity did its work over billions of years. It pulled matter into dense nodes and connecting filaments. And in doing that, it drained matter away from other regions. Those drained regions became the cosmic voids. So the emptiness isn't a leftover, it's a consequence. The other side of creation's coin, the luminous universe, is painted on a canvas of profound, structured nothing. To see why the voids matter, you have to see this web they define. It's the stage. The voids are the vast, open spaces between the actors. Without that space, the play doesn't unfold. This cosmic web isn't just a theory. It has a name, it has a location, and the scale is hard to believe. 700 million light-years away, in the constellation Boötes the Herdsman, there's a part of the universe that's mostly empty space. Astronomers call it the Boötes Void. Its nickname is the Great Nothing. When they found it in the 1980s, it was a puzzle, a sphere of space so huge you could fit thousands of galaxies. But surveys only found a handful. Where you'd expect a crowded city of stars, there was just silence. This wasn't a small gap, it was a cavern, a place where the normal rules of where matter goes seemed to stop. The Boötes Void challenges our intuition. We think the universe should be smooth on the largest scales, but this was evidence of unevenness, a design that included these huge deserts. The Great Nothing became a case study. It made scientists look closer, and when they did, they saw that even emptiness has texture. The void isn't a perfect vacuum. Those few galaxies inside it are like islands in a dark ocean, and they're strange, isolated. No gravitational tug of war, no rich gas flows from crowded filaments. They evolve in peculiar ways, often older, quieter, starved of the material to make new stars. They become relics, preserving a quieter state. So the Boötes Void is a natural laboratory. It shows what happens to a galaxy cut off from everything else. It lets us see the environmental forces that shape all galaxies. It teaches a subtle lesson. Cosmic emptiness isn't absolute. It comes in degrees, from small gaps between clusters to these billion light-year abysses. Each variation of nothingness is a data point. It helps cosmologists refine their models, how dark matter and dark energy sculpt the universe. The Boötes Void is more than a curiosity. It's a physical monument to absence. A blank page in the cosmic story. Its existence tells us the universe's design needs these quiet spaces to give meaning to the light. The great nothing is a fossil. It's a preserved imprint of the universe's past. But to understand why voids matter, you have to look at the universe's most mysterious actor, a force that writes the future in empty space. That's dark energy. It's just the name we give to whatever is causing the cosmos to expand faster and faster over time. It's a repulsive force woven into space itself. And it works everywhere, but it finds its greatest freedom inside the cosmic voids. Think of the universe as that stretchy fabric. Where matter is dense in galaxy clusters and filaments, gravity is strong. It pulls the fabric inward, creates a deep well. That gravitational pull acts as a brake, a local resistance to the outward push of dark energy. But in the empty voids, there's almost no matter. Almost no gravity to fight back, so dark energy operates unimpeded. The voids don't just expand with the universe, they expand faster than the cosmic average. They become the primary engines of the universe's large-scale motion. They're the fingerprints of dark energy on the cosmos, as physicist Laura Mersini-Horton has put it. And this isn't subtle. This accelerated expansion inside the voids actively stretches the cosmic web. It pulls on the filaments. It influences how they evolve, how clusters of galaxies move over billions of years. Picture a growing sponge. As the holes inside it get bigger, the solid walls between them are stretched and thinned. The emptiness isn't passive. It's an active, dynamic sculptor. Powered by dark energy, the voids are carving the future shape of everything. They are the chambers where the universe's ultimate fate is being decided. Not in the crowded cities of stars, but in its vast, silent deserts. Gravity sculpts the universe, but to do that, it had to create emptiness first. It started with a whisper. Right after the Big Bang, everything was almost perfectly smooth. A hot soup, almost uniform, but not quite. Because of quantum mechanics, there's always a tiny jitter. A faint uncertainty, and that planted the seeds, microscopic ripples. Some spots were a tiny bit denser, others a tiny bit thinner. Those were the blueprints. Then gravity got to work. It's patient. It works over billions of years. It plays favorites. A spot with a little more matter has a slightly stronger pull. That pull attracts more matter, which makes it denser, which increases its pull. It's a snowball effect. Matter flows into these knots, but for every winner, there's a loser. The spots that started with a little less matter had a weaker grip. Their denser neighbors grew more powerful and began to steal matter away. That's the feedback loop. It doesn't just build up, it empties out. Think of a crowded plaza. A few people gather around a performer. That gathering attracts more people. The crowd grows. And soon that spot is packed. But to create that packed crowd, you had to drain people from the surrounding areas. Those areas become emptier, precisely because the crowd formed. The cosmic voids are those emptied areas. They're not random holes. They're the inevitable result, the complementary result of structure forming. They're the background. The cosmic background, against which the glittering foreground of galaxies emerges. Without this draining action, this selective pull, matter would stay in a fog. A uniform state, the great walls, the filaments, the superclusters might never have come together. So emptiness isn't an accident, it's a direct consequence. A necessary one. It's the negative space carved out by the same hand that drew the stars. That fossilized bubble holds a story written in geometry. In the size of a void, its shape, its place in the pattern of other voids, and the truth is, the emptiest places in the cosmos are the cleanest archives. They hold the best record of how it all began. Think of a city street after a snowfall. That clean blanket gets trampled, turned to slush by footprints. That's what happens in the dense parts of the universe. Galaxy collisions, supernova, the gravitational tug of war inside clusters. It all churns the record. It overwrites the original signal with noise, but a void is like a remote field. That same snow lies undisturbed. The original shape of the land is preserved underneath. For cosmologists, that original shape is the pattern of the universe's first whispers. Those quantum fluctuations from right after the Big Bang, the blueprint. In the crowded neighborhoods of galaxy clusters, that blueprint's been remodeled, built over, but in the quiet voids, it's still legible. The way voids are spread out, their preferred sizes and shapes, that's a direct message from the universe's first trillionth of a second. It's a test for our theories of cosmic inflation, that moment of rapid expansion that stretched those quantum seeds everywhere. Different inflation models predict different patterns for the cosmic web. And so, a different statistical fingerprint for the voids. So scientists don't just find voids, they take a census, they measure thousands, they ask, are they round or stretched? What's the most common size? How are they spaced? This data is like a cosmic barcode. Scanning it tells us about dark matter, that invisible glue. Was it cold and slow? Or slightly warm? The way voids form depends on that. So each void is a fossil, not of a creature, of a moment of creation frozen in the architecture of absence. By studying nothing, we read the opening lines of the universe's story. It turns intuition inside out. Emptiness isn't a lack of information. It's information in its purest form. The great silent voids are speaking, and they're telling us where we came from. Our home in the cosmos is shaped by emptiness. The Milky Way isn't in a busy center of stars. We're on a quiet, suburban edge on the fringe of a filament in the cosmic web, and right next to us is a huge, dark border, the local void. It's not an abstract idea. It's our neighbor, a space so empty it goes on for hundreds of millions of light years, with almost no galaxies inside it. Our place next to this great nothing has written the story of how we move. The local void doesn't push us, gravity only pulls, but an imbalance of pulls creates a kind of push. The Virgo supercluster, in the opposite direction from the void, has a much stronger gravitational grip on our galaxy. It tugs us toward it, and the empty local void has almost no pull at all. So the net effect is, we're pulled so strongly away from the void that it feels like being pushed. Our galaxy, our whole local group, is sailing on that current, flowing away from the emptiness and toward the density. That motion isn't random, it's because of our address. We're on the slope of a gravitational hill, rolling down toward the crowded supercluster because the land behind us is flat and empty. This quiet neighborhood gave another gift: stability. Being near a void means our corner of the universe has been calm for billions of years. We haven't faced the violent tides and the frequent galaxy collisions that happen in dense cluster cores. In those crowded places, solar systems get disrupted. Planetary orbits get scrambled before life can start. Here, on the frontier of nothing, our sun had the time and the quiet to form. Earth had the long, uninterrupted eons for chemistry to become biology. Our cosmic address on the border of a void might be one of the most important and overlooked reasons we exist. It connects the vast, essential emptiness of the universe to the chance for a planet like ours. The silence of the void gave us a stable stage for our story to begin. That quiet, isolated life out there, it shapes a galaxy in really deep ways. If you went to a galaxy floating in one of those cosmic voids, you'd find a different world. Astronomers have a name for them: void galaxies. They're the hermits. Everywhere else in the clusters and the filaments, it's like a crowded city, but these ones, they live in near total solitude. And that isolation, it's not a bad thing. It's just a different existence. It actually shows you the basic rules of how a galaxy grows and changes. Think of a galaxy cluster like a metropolis. Galaxies are always moving, brushing past each other, sometimes colliding. They're sitting in this hot intergalactic gas. Their own fuel for making stars gets stripped away by the gravity of their neighbors. It's a violent place. It forces galaxies to evolve a certain way, often into those giant, red, dead ellipticals where nothing new forms. But then you go out to the void. A galaxy out there might be the only major thing for tens of millions of light years. A real island universe, and that solitude changes everything. Without neighbors harassing it gravitationally, a void galaxy keeps its gas. That gas is the raw material, so while a void galaxy might form stars more slowly than one in a big merger, it can do it more steadily for much, much longer. It's not in a rush, it's a quiet, sustainable life. Their shapes tell you something, too. Without all the tugs and pulls of a crowded place, void galaxies often keep more irregular, pristine forms. They're more likely to be beautiful spirals full of gas or quirky, misshapen dwarfs. They're not molded from the outside. They're shaped from the inside out by their own internal dynamics. By the slow, gentle gathering of the thin gas that drifts through the void. Studying them is like watching a single plant grow in a peaceful greenhouse. Instead of a forest where everything's competing and overshadowing each other, that makes void galaxies a kind of cosmic controlled experiment. You take a void galaxy and compare it to a similar one in a cluster. You can ask a powerful question: what in this galaxy's behavior is its own nature, and what is just a reaction to its environment? The void galaxy shows you the baseline. What a galaxy does when it's left to its own devices. It helps scientists untangle cause and effect in how galaxies evolve. So these lonely galaxies, they're not failed. They're not forgotten. They represent a specific niche, a necessary one in the universe's design. Emptiness provides the quiet space for this other lifestyle to unfold. It allows for a diversity of forms and life cycles that a uniformly crowded universe couldn't support. The cosmic ecosystem needs both, the vibrant, intense cities and the vast, silent wilderness. And out in that wilderness, the void galaxies keep going, their slow, steady dance, writing their own unique chapter in the story. That ancient blueprint is still visible. It's a faint, cold glow we call the cosmic microwave background, the oldest light in the universe, a snapshot from when everything was a hot, dense fog. And when scientists look at this map, they see a pattern, tiny temperature variations. Some spots are a fraction of a degree warmer, others a fraction cooler. These minute differences, just millionths of a degree, they're the quantum seeds now frozen in light, and there's a profound connection, the slightly cooler patches in that ancient light. Those are the regions where, billions of years later, the great cosmic voids would form. The blueprint for emptiness was there from the very first moments. Written into the fabric of reality before a single star had ignited. So the voids we see today, like the Boötes Void, they aren't accidents. They're the grown-up versions of those primordial cool spots. Their destiny was set when the universe was only 380,000 years old. Satellites like Planck have mapped this background with incredible precision. And by comparing that map of the baby universe to our maps of the cosmic web today, scientists can trace a direct lineage. They can follow the gravitational evolution of those under dense regions. As they expanded, as matter drained away, and as they grew into the vast silent chambers we now observe, this is the ultimate birth certificate for cosmic emptiness. It proves voids are not an afterthought. They're not empty because something went wrong. They're empty because the universe's original design called for them. The CMB is the foundational text, and the voids are a chapter written across billions of years. So when we look at a map of the cosmic microwave background, we're not just looking at the afterglow of creation. We're looking at the genetic code for the cosmic web. We're seeing the cold fingerprints that would, in time, sculpt the great abysses between the galaxies. The silence was there from the beginning, whispering in the cold, that faint glow from the early universe. It wasn't just about temperature, it carried sound. The cosmos was a thick, opaque plasma for the first few 100,000 years, a soup of particles and light, and in that soup, pressure waves moved out from every little density ripple. Real sound waves, a cosmic symphony, incredibly loud. Then, around 380,000 years after the Big Bang, things cooled enough for atoms to form. Light broke free and the music just stopped. The sound waves froze right where they were. They left an imprint, a fossilized echo in how matter is distributed. A single preferred scale stamped onto everything. We call it Baryon acoustic oscillations. The name is technical, but the idea is simple. Those frozen waves made a cosmic ruler. A standard measuring stick etched across the sky. Its length is set by how far a sound wave could travel in that early plasma before everything froze. That distance comes out to about 500 million light-years in today's expanded universe. So if you took a snapshot, you'd see galaxy clusters tend to be spaced about that far apart. And so are the centers of the great cosmic voids. The emptiness is part of the pattern. The voids are the troughs of those waves. The clusters are the peaks. This predictable spacing, this 500 million light-year rhythm in everything is our golden calibration. It's a fixed reference, a known size. Think of a balloon with a grid of dots. You inflate it, the dots move apart. But because you know the original grid spacing, you can measure exactly how much the balloon stretched by how far apart the dots are now. Baryon acoustic oscillations are that grid printed on the universe. The voids and clusters are the dots. By looking at galaxies and voids at different distances, which means looking back in time, astronomers can measure this ruler at different epochs. How big does this pattern look when we see the universe 7 billion years ago? How big 3 billion years ago? How big nearby today? The answers tell a precise story of cosmic expansion. They show how the stretching of space has changed over time, and this is where the voids become essential. They're so clean, unaffected by the messy physics of individual galaxies. Their average size is a pure signal. Measuring the geometry of emptiness gives us a clean read on the geometry of spacetime itself. This data has become one of the strongest constraints on dark energy. It tells us how the repulsive push of dark energy has accelerated the expansion over billions of years. So the great silent voids aren't just passive. They're active participants in the biggest measurement we can make. They're the fiducial marks, the etched lines on the grandest caliper. By studying the size of nothing, we measure the growth of everything. This cosmic ruler is a scientific triumph, but the idea of a void, it resonates beyond our telescopes. We've always looked up and we've looked inward. The emptiness of space has mirrored an emptiness in human thought. Across cultures, across centuries, the void is this central, haunting idea. In ancient Buddhist philosophy, there's sunyata. Emptiness, but it's not a bleak nothingness. It's a state of openness, of potential. A positive absence that lets all things exist without a fixed identity. It's the fertile ground where form arises. Then centuries later, in the West, Blaise Pascal looked at the starry sky. He felt something very different. He wrote about being terrified by the eternal silence of these infinite spaces. For him, the cosmic void was a spiritual abyss, a confrontation with a universe indifferent to human concerns. So you have these two poles. One sees generative potential in emptiness. The other sees a chilling reminder of our smallness. And the cosmic voids we map now, they're a physical manifestation of these ancient ideas. They are the sunniota of the cosmos, the vast open chambers that let the cosmic web take form, and they are also Pascal's infinite silent spaces, made real on a scale he couldn't imagine. This connection, it's more than poetic. It challenges a bias we all carry. This idea that the universe must be designed for beings like us, that it should be comprehensible. Comforting, full of meaning for human experience, the voids defy that. They are spectacularly indifferent. They exist by physical laws, not to provide a habitat or a lesson. Their nature forces a perspective shift, a humbling one. It asks us to reconsider where we find value. We prize matter. We prize light and activity. We see a galaxy and think that is something. We see a void and think that is nothing, but the scientific story flips that. The nothing is not a lack. It's a fundamental, active, structuring principle. The emptiness has a shape. It has a history, a function. It's as much a part of the universe's design as the stars. This philosophical dimension, it doesn't contradict the science. It enriches our understanding. It connects the external cosmos to the inner landscape of human meaning. When we study a void, we're not just measuring dark energy. We're engaging in an age-old dialogue. We're asking what it means to exist in a reality so vast that most of it is defined by absence. The silence of space becomes a mirror. And in that mirror, we see our own questions reflected back against the darkest possible backdrop. The philosophical void raises a question about reality. But to answer it, we need to be precise. When we talk about cosmic voids, those billion light-year spaces, we're not talking about a perfect vacuum. The deepest space between galaxies isn't a true nothingness. It's a place of profound quiet, but it's not empty. Even in the heart of the Boötes Void, far from any star, space isn't a void in the absolute sense. It contains a whisper of matter, a few hydrogen atoms per cubic meter, the faint glow of the cosmic microwave background, cosmic rays passing through. It's a sparse, thin soup, but it's not nothing. And beneath that, according to our best physics, is something more fundamental. Quantum field theory says what we call empty space is a seething, dynamic arena. A quantum vacuum, it's not passive. It's a state of minimum energy but not zero energy. At the tiniest scales, virtual particles wink in and out of existence. Fleeting pairs of matter and antimatter, borrowing energy for a moment before annihilating. This quantum froth isn't matter as we know it. It's a property of space itself. The bedrock for all particles and forces, so there's this duality. A cosmic void is a macroscopic emptiness. On the scale of galaxies, it's a desert. A region drained of large-scale structure, but on the quantum scale, it's as full and active as the space around Earth. The quantum fields are everywhere, always on. The void is a lack of classical matter on top of a quantum fullness. That distinction is critical. It prevents a misunderstanding. It keeps us from seeing voids as absolute, sterile nothingness. They aren't holes in reality. They are regions where the fabric is exceptionally smooth and quiet on one level, while still humming with potential on another. This quantum sea has consequences. It's thought to be the source of dark energy, the force accelerating the universe's expansion. The energy of the quantum vacuum, if it has the right properties, could be the engine behind the void's own growth. So the large-scale emptiness we see is connected to the quantum activity we can't see. One creates conditions for the other. Understanding that reframes everything. The cosmic void isn't an absence of physics. It's a specific, extreme environment for physics. A place where the classical pull of gravity has almost vanished, letting the subtler effects of quantum fields and dark energy take over. It's a laboratory of minimalism, where the universe strips away the clutter of stars and gas to reveal the underlying canvas, a canvas that is, itself, alive with invisible activity. The great silence isn't an end, it's a different kind of presence, and in that quiet, we might hear the faint hum of reality's deepest rules. That quantum hum, the energy underneath space, is writing the last chapter. The voids we see now, they aren't static, they're growing, and that growth is speeding up, pushed by the same dark energy that makes them such good probes. Over billions of years, these silent chambers will expand. Their walls will thin, neighboring voids will start to touch, and then merge, swallowing the last delicate threads of the cosmic web. The universe's structure will be stretched until it breaks. If you could look out from our galaxy, trillions of years from now, the expansion of space would have carried every other galaxy cluster beyond an invisible horizon. Their light, no matter how strong, could never reach us again. The night sky for any future civilization here in our local group would be profoundly dark. Only a handful of gravitationally bound companion galaxies would still be visible, like dying embers in an immense black cavern. Their entire observable universe would be a void, just a few dim, aging stars left. The cosmic isolation would be absolute. This isn't speculation about alien life. It's a direct prediction from our physics, just pushed forward. The fate of all cosmic structure is to be diluted by this accelerating emptiness. That trajectory has a name, a quiet and profound endpoint. Scientists call it the heat death or the big freeze. It's a state of maximum entropy where energy is spread out evenly. No hot spots, no cold spots, no gradients left to drive any process from star formation to thought. The universe becomes a vast, ultra-cold, nearly uniform sea of diluted particles and radiation. A cosmic void in the truest, most final sense. So when we map the Boötes Void or measure the local void today, we're not just studying the universe's past or its present architecture. We're looking at a preview, a glimpse of the universe's ultimate form. The emptiness isn't an intermediate stage. It is the destination, the vibrant cosmic web with its brilliant galaxies and swirling nebulae. That's a temporary spectacle. A fleeting pattern of density against the void. The void is the background that will, in time, become the entire picture. This gives our study of cosmic voids a profound, almost philosophical urgency. They are a window into an inevitable future. By understanding how they form and grow now, we're tracing the arc of the cosmos itself from a hot, dense beginning to a cold, silent end. It means the essential role of voids isn't just about shaping space, it's about defining time. They show us where the story is ultimately headed. A story where, in the end, the silence is all there is. The universe is built to include these huge empty spaces. There's the giant void in Eridanus. It's another one of these massive regions, about 500 million light-years across, and it's deeply, profoundly empty. Finding it wasn't a surprise, it was more of a confirmation. It locked in this understanding that voids aren't rare accidents, they're common, they're significant. They're as much a part of the structure as the galaxy clusters themselves. The scale of the Eridanus void is what makes it useful. Its size is a measurement. That 500 million light-years, that's a key number. It's the length of that frozen sound wave from the early universe, the Baryon acoustic oscillation. A void that big isn't just large, it's a calibration point. It lets scientists tune their models of how structure forms. It tests the limits of the theories. With the amounts of dark matter and dark energy we know, and the physics we have, how big can an underdense region actually get? The Eridanus void sits right at that edge. Its existence is a quiet challenge. It pushes the models, asking if the calculations are complete, or if there are subtle processes in the cosmic web we're missing. This void is a stress test, and yet, even in this desert, there's life. A few galaxies drift in the emptiness. They're not mistakes, they're clues. By looking at them, astronomers can trace a delicate process. How does matter, the gas for stars, actually flow into a void? It doesn't just appear, it has to come from somewhere. The leading idea is a slow trickle. Thin streams of hydrogen gas pulled from the surrounding filaments might seep in over billions of years. This is cosmic recycling on the grandest scale. The filaments feed the clusters, but they also bleed a little into the voids. Studying the galaxies inside the Eridanus void lets us see this process in its simplest form. How do these galaxies get their fuel? Is it from that slow infall or from consuming smaller companions? Their answers tell us about the metabolism of the cosmos. So the giant void in Eridanus isn't just another empty spot. It's a laboratory of extremes, a calibration tool, a test of physics, and a window into the subtle flows that govern space. Its existence shows that emptiness isn't an error in the blueprint. It's a feature, a necessary negative space that gives the whole thing its form. There's a conductor to this galactic ballet. The cosmic voids, they aren't just empty stages. They're the source of the motion. As these vast regions expand, pushed by dark energy, they do something. They set entire rivers of galaxies in motion. That's the kinetic role of emptiness. Think of a slow continental drift, but on a scale so large it holds thousands of galaxies. They're called bulk flows, great cosmic currents where galaxies move together like leaves in a gentle, universe-wide breeze. And the source of that breeze is often the growing void right next door. A galaxy sitting on the filamentary wall of a void, it isn't still, it's streaming, flowing along the filament, usually in a direction that carries it away from the void's center. That's a galaxy's peculiar velocity, not its motion from the expansion of space, but its own individual journey through space, laid over that grand backdrop. It's the difference between standing on a moving walkway and walking on it. The expansion is the walkway. The peculiar velocity is your own steps, and for many galaxies, those steps are directed by the geometry of the surrounding emptiness. By mapping the directions and speeds of these galaxy streams, astronomers can do a kind of cosmic echolocation. They can trace the shape of the unseen. The motion reveals the mass. If galaxies are flowing away from a certain point, that point must be underdense, a void. The strength and pattern of the flow show the void's size and depth. And it maps the distribution of dark matter, the invisible skeleton that defines the void's gravitational profile. So there's this circular logic. We find voids by noticing where galaxies aren't. But we also understand voids by watching how the galaxies that are there move. Their motion is a fingerprint left by the gravitational absence of the void. This turns our idea of influence upside down. We're used to thinking of dense, massive objects as the prime movers, a black hole pulling on stars, a galaxy cluster bending light. But here, it's the lack of mass that's doing the pulling. Or really, it's the imbalance. The stronger gravitational pull from the dense regions on the other side of the void creates a net force that draws galaxies away from the emptiness. The void is the hole in the tug-of-war rope. The teams on either side pull, and everything near the hole moves toward them. So the silent, expanding voids are dynamic sculptors of motion. They set trajectories that will play out over cosmic epochs. They orchestrate the slow drift of galactic superclusters, this grand kinetic dance where thousands of galaxies stream together is choreographed not by the brightest lights but by the darkest spaces between them. To call a place in space a void, it's not just about finding a spot with no galaxies. That's too simple. The universe doesn't work that way. Astronomers have to set a line. They take these huge 3D maps from galaxy surveys, maps with millions of points of light, and they run computer algorithms. The algorithms look for large, connected regions where the galaxy density drops below a certain threshold. That threshold is usually around 10% of the cosmic average. So if the average universe has one large galaxy per 10 million cubic light-years, a void is where you'd need to search 100 million cubic light-years to find one. It's a region drained of the usual glitter, but that 10% line, it's not a law of nature. It's an operational definition, a tool. Scientists pick it because it gives them a clear, consistent way to find and compare these empty bubbles. Change the threshold and you change the census. A stricter definition, say 5%, might only find the deepest voids like the Boötes Void. A more lenient one, like 20%, would include larger, fuzzier regions with a few more galaxies. Each choice shows a different layer of the cosmic web's anatomy. This technicality matters. It shows that emptiness in science isn't a philosophical absolute. It's a measurable, relative condition. It's a spectrum. By defining a void, cosmologists do something. They turn the abstract concept of nothing into a quantifiable entity. They give it a boundary, a volume, a shape they can put into their equations. That framework lets them ask precise questions. How does the size distribution of voids match dark matter theories? How does their growth rate constrain dark energy? Defining the void transforms it from a mere absence into a positive component of our models. It becomes a variable, a parameter that can be tested. So when we talk about the local void or the giant void in Eridanus, we're not just pointing to a blank spot. We're referencing a carefully catalogued feature of the universe defined by a specific lack. This is how science grapples with the profound. It starts by measuring the shape of the silence. That measured silence is also a prediction made in silicon. To understand why the voids are necessary, you have to go into a different kind of lab, a virtual universe built from mathematics and computing power. The deepest insights come from building worlds from scratch. Scientists don't just look at the sky, they write the laws of physics into code. They feed that code into supercomputers. And then they press start. They simulate everything from just after the Big Bang through 13.8 billion years of expansion and gravity. These aren't animations, they're titanic calculations. Projects like the Millennium Simulation or IllustrisTNG, they track trillions of particles, clumps of dark matter, parcels of gas, all moving under gravity. And every single time, these simulated universes produce the same structure, a vast cosmic web, filaments of simulated galaxies, and between them, these vast, dark, growing voids. The simulations don't program the voids in. They're not an artistic choice. They emerge naturally from the starting conditions and the laws we provide. That's the ultimate test. If our cosmology is right, the right mix of dark matter, dark energy, ordinary matter, then a virtual universe should grow to look like ours. And it does. The simulated voids have the right sizes, the right shapes, the right distribution. They match the fingerprint of the Boötes Void, the Eridanus Void. That match isn't a lucky guess, it's a confirmation. It tells us the emptiness isn't an anomaly we have to explain. It's a required output, a direct output of the universe's operating system. But the simulations are more than validation. They're a playground, a cosmic lab. Scientists can run experiments that are impossible in reality. They can dial up the strength of dark energy and watch the void swell faster, stretching the web. They can tweak dark matter, make it warmer, and see how the pattern of emptiness changes. They can rewind time inside the simulation, watch the birth of a specific void, trace which streams of matter flowed away and which faint galaxies were left behind in the stillness. This virtual experimentation is how we stress test our understanding. When a simulation based on our standard model produces a universe that looks uncannily like our own, complete with its great silences, it builds confidence. It means the emptiness we see isn't a bug in the cosmic code. It's a feature, a predicted feature, an essential one. The success of these digital universes in replicating the voids we map is perhaps the strongest silent argument we have. It validates the whole story, from quantum whisper to grand web, with structured nothingness as a central, undeniable character. The virtual universe confirms the science. But we still want to grasp it, to feel it, and that's where art comes in. the cosmic web has become a defining image of our time, this modern masterpiece painted with telescope data. It translates abstract physics into something we can feel, the beauty of that structure, the elegant balance between the glowing filaments and the immense silent voids. It evokes awe. A graph of numbers can't do that. It makes the scale real, the intricate design. We see the pattern and we understand. We're looking at the architecture of everything. Artists have always been drawn to this, to light and absence. Someone like Rafael Araujo, he draws intricate webs, not galaxies, but the underlying mathematical structures that might govern them. His work is built from geometric principles, the golden ratio. It mirrors the cosmic web's own emergent order, that same essential harmony, beauty arising from the tension between form and the space that defines it. In these works, the void isn't a blank margin. It's an active participant, a necessary negative space. It gives the luminous lines their meaning, their power. This artistic interpretation does more than decorate. It provides a gateway. For many, a stunning visualization of the cosmic web is the first spark. It leads to deeper questions about dark matter, dark energy, our place in the grand scheme. This aesthetic appreciation is a vital part of understanding. It fuels public engagement, turns complex science into shared cultural imagery. When we look at a beautiful rendering of the universe's structure, we're doing more than learning. We are experiencing, we feel the solitude of a void galaxy, the immense stretch of a filament, the fragile nature of our local neighborhood. The void in art becomes a space for quiet reflection. Just as it is a physical chamber for cosmic evolution, it mirrors that philosophical role. It invites us to project our own questions onto its dark canvas. So the contribution of emptiness extends beyond physics into human culture and emotion. It shapes how we visualize the universe and therefore how we comprehend it. The silent voids give the cosmic web its iconic form, a breathtaking form, one that continues to inspire scientific discovery and the human imagination. These artistic visions point to something deeper, a possibility that's almost unsettling. The voids we map, those vast, silent chambers, might be more than just features of our universe. They could be evidence of something beyond it. This idea goes into the most speculative parts of cosmology, where the emptiness inside our cosmos hints at a reality that's far larger. Some theoretical physicists have proposed a connection. Alexander Vilenkin is one. The immense, under dense regions we call voids could be signatures. Scars from ancient collisions with other universes entirely. In the framework of eternal inflation, our entire cosmos is just one bubble. It nucleated in a much vaster, eternally inflating meta-universe, a frothing sea where countless other bubble universes are constantly budding into existence. Each with its own laws of physics, so space itself is a multiverse, and sometimes these expanding bubbles can collide. When they do, the impact would send a tremendous shockwave through both universes. In ours, a collision in the distant past would have deposited an enormous amount of energy. Then, as the universe expanded and cooled, it would have left a distinct imprint. What would that imprint look like today? It might be a strange, circular pattern in the cosmic microwave background, a bruise on the oldest light, or, as some models suggest, it could have created a vast, persistent region of underdensity. A void on a scale that's difficult to explain through internal processes alone. A cosmic void, in this view, is not just an absence shaped by dark energy and gravity. It could be a boundary marker, a place where our universe once brushed against another reality. This is, of course, highly speculative. It sits at the very edge of testable science. But the implication is profound. By studying the detailed structure of the largest voids, their exact shapes and temperature profiles, we might be searching for evidence of other realms. The great nothing becomes a potential window. It elevates the significance of cosmic emptiness. from a structural feature to a possible metaphysical portal. These silent spaces are no longer just the backdrop for our story. They become the thin walls in a grander hotel of realities. We have no definitive proof. But the mere possibility reframes our entire investigation. Every precise measurement of a void's geometry, every search for anomalous patterns within it, takes on a new weight. We are no longer just cosmologists mapping our home. We are potential cartographers of the multiverse, using the shape of nothing as our guide. The idea of other universes makes you wonder something more direct. Could a universe even exist if it didn't have voids? You have to rewind things, take away the great empty chambers. Picture a universe where matter was spread almost perfectly even from the beginning. No deep underdensities, no vast silent deserts, just a smooth, uniform fog of galaxies. What happens then? The story of structure changes completely. Without those initial cool spots, those seeds for emptiness, gravity's work becomes far more local. It pulls matter into clumps, but those clumps are smaller. More numerous. You don't get a grand cosmic web with its majestic filaments and cavernous voids. You get a universe of countless tiny island groups, a crowded, bustling metropolis with no open countryside. And that environment becomes extraordinarily violent. Galaxies are packed together, their gravitational fields constantly tangling. Close encounters, near misses, catastrophic mergers, they're commonplace. Not rare events separated by billions of years. In a universe like that, a typical spiral galaxy like our Milky Way is an impossibility. Its delicate disk structure gets shredded by gravitational tides long before it can fully form. The beautiful, orderly rotation we see turns to chaos, and within that chaos, solar systems have no peace. A star with planets orbiting serenely for billions of years is a fragile thing. In a galaxy constantly being jostled and merged, planetary orbits get flung into disarray. A planet like Earth, sitting in a stable, temperate zone for over 4 billion years, allowing chemistry to slowly, patiently build the complexity of life that almost certainly doesn't survive. The long-term stability we take for granted becomes a cosmic luxury. This is where the cosmic voids connect to us intimately. They aren't just out there. They are here. By creating the vast, quiet backwaters of the universe, the voids sculpted the environment that made our galaxy possible, made our solar system possible. The Milky Way exists in a relatively quiet suburban filament on the border of the local void. That emptiness next door is a buffer. It guarantees a certain gravitational calm. It provided the peaceful nursery where our sun could form and our planet could orbit uninterrupted for eons. From an anthropic view, this is profound. The presence of these vast empty regions might be a necessary condition for observers like us to ever arise, to ask questions about the cosmos. The universe could only become aware of itself in the quiet neighborhoods, not in the dense, violent downtown cores of galaxy clusters. So when we marvel at the great nothing, we're not just looking at an interesting feature of distant space. We're looking at a foundational piece of our own origin story. Emptiness, in this cosmic sense, isn't an absence of meaning. It's the very canvas of quietude upon which the possibility of meaning was painted. The silent voids, therefore, are an unsung prerequisite, a necessary emptiness that made our existence not just possible but probable. That isolation, the quiet that allowed us to exist, it also creates a kind of prison. For a civilization looking out with ambition, these cosmic voids are a barrier, a final one. They're not just empty space, they're deserts, on a scale that human engineering can't really touch. The practical problems for travel or for communication across a void, they aren't just difficult. With the physics we know, they're almost insurmountable. Take a voyage, a ship, even one going a good fraction of light speed, heading out to cross a void. Like the one in Boötes, for millions of years it would find almost nothing. No nebulae to use for fuel, no star clusters to act as waypoints. It's an ocean with no islands. The emptiness itself becomes a wall. The void gives you no sustenance. No refuge, no shortcut, and then communication. A radio signal, a laser beam, sent from one filament of the cosmic web to another, across that gulf, it weakens. To a whisper, the signal disperses, fades with the square of the distance. Against the background noise of the universe, it's just lost. So these voids, they act like natural moats. They're not just gaps in matter, they're gaps in possibility. They could quarantine entire galactic superclusters from each other, isolating any life that arises. Which brings us to that question, the Fermi paradox. If the universe is so vast, so old, with so many planets that could support life, why no evidence? No signals, no visitors. The cosmic voids offer an answer, an elegant one. It's not that intelligent life is rare, it could be common, but it's permanently, physically isolated. Each filament of the cosmic web, each rich neighborhood of galaxies could be teeming with civilizations, and they would be forever separated by billion light-year expanses of nothing. The voids are the ultimate quarantine, built into the architecture of reality. The design of the universe with these essential empty regions may inherently limit connectivity. That shapes a kind of cosmic sociology. A civilization might rise, look out, map the web, and realize something. Their entire observable universe, their entire sphere of possible contact, is their local filament. And the voids around it, the glittering cities in other filaments, aren't just far. They're fundamentally unreachable, receding forever because of the accelerated expansion the voids themselves drive. So you get a picture, a cosmos of islands, islands of awareness, each singing its own song into a surrounding silence, a silence so vast the music never reaches another shore. The emptiness that made us might be what keeps us alone forever. We're sitting inside a cosmic void, and right next to it there's another one, the northern local void. So we're actually sitting between two of these huge, empty regions, and trying to map that from the inside it's like trying to figure out the shape of a cathedral while you're standing somewhere inside it. So instead of just plotting where galaxies are, projects like Cosmic Flows look at how they're moving. They measure the velocities of thousands of nearby galaxies. And from that motion, you can work backwards. You can infer the gravitational landscape, the hills and valleys of mass that must be causing it. That technique gives you a 3D map of the density around us. And what it shows is we're in a filament, a bridge of matter. To one side is the local void, on another side, pressing in, is the northern local void. They're not isolated bubbles, they're connected chambers, a local sponge of emptiness, carved out by the same ancient processes that shaped the whole cosmic web. And this map isn't just a curiosity, it's why we're moving. The specific gravitational pull we feel, the path the Milky Way is taking, comes from the arrangement of these nearby voids and the denser filaments opposite them. It tells us exactly why we're moving in this direction at this speed. Even Andromeda's path, its future collision with us, is set within this same framework shaped by the surrounding emptiness. So our local neighborhood becomes a case study. We can see in high definition how voids interact with each other and with the filaments between them. How their combined gravity orchestrates a local dance of galaxies. And that perspective, it grounds the idea. It shows that the structuring role of empty space isn't just a feature of the distant, early universe or far-off voids like Boötes. It's a fundamental architectural principle. It shapes the largest superclusters and it shapes the path of our own sun. These cosmic voids aren't out there. They're here, defining the contours of our backyard. When we map the silent spaces next door, we see it clearly. We live not just in a universe of stars, but within a sculpted geometry of presence and absence. Where the empty chambers are as defining as the shining walls. That profound quiet we inhabit, it's defined by what isn't there. a cosmic void isn't just a place with few galaxies. It's a region starved of the ingredients that build them. The space inside a void is missing something fundamental, the ordinary, tangible stuff of the universe. Protons, neutrons, electrons, the things that form every star, every planet, every speck of cosmic dust. Astronomers call that baryonic matter. In the dense filaments and clusters, it's abundant. But inside a void, its density can be less than a tenth of the cosmic average. It's a place of material poverty, and that scarcity goes deeper than just a lack of visible objects. In the rich neighborhoods, the space between galaxies isn't truly empty. It's filled with a seething, superheated fog, the intracluster medium. This gas is incredibly thin by Earth standards, but it's millions of degrees hot. It glows in X-rays. It contains more material than all the galaxies in the cluster combined. It's the reservoir, the fuel supply for future stars, but in a void, that reservoir is almost completely absent. The hot, diffuse gas has been siphoned away, pulled by gravity into the denser filaments and clusters over billions of years. The void is left with a cold, ultra-thin medium. A near vacuum, and this specific absence has consequences. First, it starves any galaxies that do reside in the void. Without a rich surrounding medium of gas to siphon, these isolated galaxies have little fuel to form new stars. They age in quiet solitude. Their star-forming fires slowly burn out. They become cosmic relics, preserving an older state of the universe. Second, this material poverty creates a uniquely clear window. Light traveling from a distant quasar or galaxy on a path that takes it through a cosmic void encounters almost nothing to scatter or absorb it. There's no hot gas to blur or distort the signal. This lets astronomers use voids as pristine sightlines. They can study the faint, ancient light from the earliest galaxies with minimal interference, seeing further and clearer than they could through the crowded districts of the cosmos. Finally, the temperature tells a story. Where matter is dense and crowded, particles collide. Friction builds and temperatures soar into the millions of degrees. But in the void, with so few particles to interact, the environment remains profoundly cold. Just a few degrees above absolute zero, and this isn't a passive cold, it's an active state, a direct result of the void's history and its ongoing expansion. The emptiness has actively expelled the heat, maintaining its own frigid stillness, so this material poverty isn't an accident of neglect. It's a defining characteristic. Sculpted and maintained by the same gravitational forces that built the glittering web, the void is a specific environment, shaped as much by what it lacks as by what it contains. Its cold, clear, fuel-starved nature is essential. It provides the contrasting backdrop that makes the luminous structures shine, and it offers the clean laboratory conditions to see the universe as it truly is. Gravity bends light. We see that with massive objects. A galaxy cluster can warp spacetime so much it acts like a lens. It stretches the light from galaxies behind it into arcs and rings. That strong lensing, it shows the power of concentrated mass, but emptiness has an effect too. A void doesn't pull light inward, it does the opposite. Light rays diverge a little as they pass through. That's negative gravitational lensing, void lensing. Instead of magnifying background objects, a void causes a slight demagnification. A subtle stretching in a radial pattern, like spokes. The effect is incredibly faint. A galaxy cluster creates dramatic arcs. A void's signature is a statistical whisper. You can't see it in a single image. You have to combine data from thousands of void images, stack them, look for a consistent, tiny dimming and stretching of the galaxies behind them. It's a monumental technical challenge, but when it's detected, it's a direct confirmation, proof that a void isn't just a place with fewer galaxies. It's a place with measurably less gravitational pull. The light tells us the void weighs far less than the space around it. This negative lensing does more. It probes the invisible architecture inside the void. We think of voids as empty, but they aren't perfect vacuums. They contain a sparse distribution of dark matter, the universe's skeleton. The way a void lenses light, the pattern and strength of that demagnification depends on how that dark matter is spread out. Is it a smooth, uniform haze, or are there faint, wispy tendrils still threading through? The bending of light gives us a way to map that. So by studying how light travels through nothing, we are actually weighing the void. Charting its unseen dark matter contours, this turns a philosophical idea into hard physics. Emptiness isn't just a passive stage, it's an active gravitational agent. Its lack of mass creates a kind of repulsive lens, a gentle hill in spacetime that light rolls over, rather than a deep well it falls into. The great silent voids write their signature in a subtle distortion of distant starlight. They inscribe their presence by the way they let light escape. That bending of light tells you something about the void. It's not just empty space, it's a place where time is different. Time doesn't flow at the same rate everywhere. Gravity, according to Einstein, is the curvature of spacetime. Strong gravity stretches time, it slows it down. A clock near a black hole ticks slower than a clock out in empty space. That's a measured fact. Our GPS satellites have to correct for it. So if strong gravity slows time, then weak gravity, that's where the voids come in. A void has profoundly weak gravity. The spacetime there is exceptionally flat, and in that flatness, time is free from gravity's drag. A clock at the heart of the Boötes Void would tick slightly faster than a clock here in the Milky Way. We're in a gravitational valley. The void is a high plane. The difference is tiny, maybe a fraction of a second over the age of the universe, but the principle is huge. The cosmos imprints itself on time. The distribution of matter creates a chronometric landscape. Billions of years pass at different rates in different places. In dense galaxy clusters, time crawls. In the vast voids, time flows at its most unhindered pace. That has a consequence for anything happening inside a void. The slow evolution of a void galaxy, a rare collision of atoms in the dark, these events unfold against a temporal backdrop that's infinitesimally different. Over cosmic timescales, the void doesn't just sit there. It experiences time in its purest form. That makes the void a baseline, a reference for the natural flow of cosmic time. When we map these silences, we're mapping more than empty volume. We're charting regions where spacetime is closest to its flat, pristine state. The design of the universe includes this. Emptiness isn't a void in time, it's a place where time is most itself. The shape of time is woven into space. To understand the universe's form, you have to look past the galaxies. You have to look at the emptiness between them. That's a question of topology. It's a part of mathematics that looks at the properties of space that don't change when you stretch it or twist it. It's not about distances, it's about connectedness. Is the cosmos just an infinite expanse, or could it have a more intricate shape, maybe even a finite one? The answer is in the pattern of the voids. You can think of the cosmic web not as a collection of points, but as one continuous surface. The dense filaments and clusters are the solid parts. The voids are the holes. Mathematicians have a measure for this. It's called the genus. Basically, the genus counts the number of handles or holes in a shape. A sphere has a genus of 0, no holes. A donut, a torus, has a genus of 1 hole through the center. A more complex shape, like a pretzel, has a higher genus. Now apply that to the universe. A cosmos filled with many isolated, bubble-like voids would have a very high genus number. It would be a complex sponge. But if the voids are interconnected, if they merge into vast, tunnel-like chambers, the topology changes. The genus number becomes a fingerprint of the large-scale structure. By analyzing galaxy surveys, by mapping the boundaries between matter and emptiness, cosmologists can calculate this number for our observable universe. They can ask, does the pattern of voids match what we'd expect from an infinite, simply connected space, or does it suggest something else? This is where it gets profound. The topology defined by voids can reveal if the universe is finite. One possibility is that space could be multi-connected, like a three-dimensional version of a video game screen. If you fly out one side, you reappear on the opposite side. That shape is known as a 3 torus. In such a universe, light could wrap around multiple times. We might see duplicate images of the same galaxy cluster in different parts of the sky, ghostly echoes of a finite cosmos. The arrangement of the voids, their connectivity, would be the key signature for that geometry. Their size and distribution would be constrained by the overall shape of space. So the great silent voids are far more than just gaps. They are the defining negative spaces in the topological map of everything. They carve out the holes in the cosmic sponge, and in doing that, they hold the clues to the universe's global architecture. Are we living in an infinite flat plane, or within a vast, repeating crystal of space? The silence of the voids may be the only echo that can tell us. By studying the topology of emptiness, we're not just cataloging absence, we're feeling for the edges of reality itself. The shape of space is a kind of silent heritage, something we're just starting to understand, and that understanding brings a new responsibility. We dream of traveling to the stars. But then there's a question: what do we owe to the silent places, the cosmic voids? They aren't just empty, they're the oldest wilderness there is, places that have seen no star, no planet, no activity at all for over 13 billion years. They're a record, a living record of the universe in its most basic state, a baseline. So if we, or any civilization, ever get to large-scale engineering between the stars, what's our duty to these silences? Think of it like wilderness on Earth. We set aside land, not for development, not for resources, but for its own sake, to protect ecosystems, to let natural processes just unfold. We recognize some things have value beyond use, intrinsic value, a heritage for everyone and for the future. Now take that idea, expand it to the cosmos. The voids are the ultimate wilderness. They're undisturbed. Their scientific value is immense. They're our cleanest lab for studying dark energy, for hearing echoes of inflation, for understanding the pure geometry of spacetime. Any intrusion, any big activity like mining or building inside a void would change that environment forever. It would contaminate the data, erase the baseline. That leads to a radical thought. Maybe these voids should be preserves, cosmic preserves, off-limits, not because they're useless, but because their greatest use is to stay as they are. To be a reference point for all of science, and maybe for something deeper, a kind of cosmic reverence. The universe's design, as we've seen, absolutely needs these vast emptinesses. They're essential to its structure, its evolution, even to our own existence. To fill them, to industrialize them, would be to disrespect that design. Like painting over the negative space in a masterpiece because you couldn't see its purpose. This flips the script on how we see resources. For centuries, exploration has been about extraction. We see a new frontier and ask what we can take, but the voids challenge that. They ask us to consider preservation as the main goal, to value nothing not as a vacuum to be filled, but as a sacred part of the whole. This is the start of a cosmic ethic, a framework for how a spacefaring civilization might act responsibly. It suggests maturity might not be measured by our power to transform everything we touch, but by our wisdom to leave the most ancient, silent things exactly as we found them. The essential design of the voids becomes a mirror for our own growth. It asks if we can appreciate the universe not just for what it gives us, but for what it simply, profoundly is. Our eyes only see a small part of the story. The real nature of emptiness is in wavelengths we can't see. To understand a void, you have to listen to the radio whispers. Feel for the absence of X-ray heat. Watch the oldest light in the universe bend as it goes through these quiet spaces. Each part of the spectrum adds something. It confirms the void is a real physical thing, not just an optical illusion. In radio astronomy, they listen for a specific signal. It comes from cosmic rays. High-energy particles spiraling around magnetic fields in space. That creates a faint radio glow, synchrotron emission. In the dense filaments and clusters of galaxies, that glow is a constant background hum. But if you point a radio telescope at the heart of a cosmic void, something happens. The hum drops away. It goes nearly silent. That quiet on the radio band is a direct confirmation. It tells us the void is missing the ingredients for that signal, the cosmic rays, the magnetic fields that usually come with matter. The silence on the radio dial is another signature. A signature of the void's material poverty. Switch to X-rays and the contrast gets more dramatic. Galaxy clusters are brilliant in X-ray light. They glow not from stars but from superheated gas. Gas trapped in their immense gravitational grip. This intracluster medium at millions of degrees shines fiercely. Now look at a void in X-rays. The image is dark. The expected diffuse glow of hot gas is just absent. That stark emptiness in the X-ray sky is a powerful visual. It shows the void has been drained of this energetic part of the cosmic web. The seething million-degree plasma that fills other regions never pooled here. The void stays cold and clear. Maybe the most subtle measurements come from the universe's oldest light. The cosmic microwave background. This fossil glow from the infant cosmos passes through everything on its way to us, including the great voids, and as it does, it carries faint imprints. One expected imprint is called the Sunyaev-Zeldovich effect. When CMB photons pass through hot gas, like in a galaxy cluster, they get a tiny energy boost. We see a specific shadow in the CMB map at the cluster's location, but in a void where there's no hot gas, that signature shadow should be missing. Its absence is another data point. Another confirmation of the void's unique environment. There's another, subtler effect, the integrated Sachs-Wolfe effect. Imagine a photon of this ancient light entering a cosmic void. As it travels through this region of weak gravity and rapid expansion, it has to climb out, but the gravitational landscape itself is changing. It's becoming shallower because of dark energy. That gives the photon a tiny net gain in energy. When it finally exits the void and reaches us, it appears very slightly hotter than the average CMB. The opposite happens when light crosses a dense cluster. It loses a bit of energy. By mapping these incredibly faint temperature variations in the CMB and correlating them with the locations of voids and clusters, cosmologists see something. They see the dynamic hand of dark energy at work. They are witnessing, in the oldest light we can see, the direct influence of the expanding emptiness on spacetime itself. This multi-wavelength investigation builds a portrait painted not with light, but with the strategic absence of light across many energies. The optical survey shows where the galaxies are not. The radio silence confirms the lack of energetic particles. The X-ray darkness reveals the missing hot gas. And the subtle shifts in the microwave background trace the void's active influence, its gravitational and expansive influence. Together, they prove a point. The cosmic void is not an artifact of one observation method. It's not a trick of perspective. It is a real, coherent feature of the cosmos, a structured absence that registers consistently across the entire electromagnetic spectrum. This unified view solidifies the void's place, not as a curiosity, but as a fundamental, physical entity in the universe's design. That portrait is a scientific triumph. But it points to something personal. How does this knowledge feel, to know the cosmos is mostly a silent, structured emptiness, and we're inside it? That carries a weight. For centuries, the night sky meant awe and wonder, but a map of the cosmic web changes the scale. Those billion light-year voids can dwarf everything human. This feeling has a name: cosmic horror, not fear, but a deep, humbling awe at the sheer indifference. The universe's laws weren't written for us, they just are. And they carved out these immense silences as part of the design. Confronting the void can feel like staring into an abyss of our own insignificance. But the same view can trigger the opposite, a sense of profound connection. That's the overview effect, but expanded. When you grasp that the emptiness is essential, that it shapes the web, drives the expansion, made our quiet galactic neighborhood possible, something shifts. The void isn't a terrifying emptiness anymore. It becomes the majestic negative space in a masterpiece. Our existence isn't an accident in spite of the void. It's a possibility because of it. We're embedded in the architecture, a tiny, conscious part of a grand balance between presence and absence. This links the external cosmos to our internal experience. The fear comes from seeing the void as a meaningless blank. The appreciation comes from understanding its role. It's the canvas, the silence between the notes that makes the symphony. The open chamber that gives form to the walls, recognizing that transforms perception. You move from feeling small in a vast emptiness to feeling connected to a vast, elegant structure. The search for meaning doesn't have to fight against the void. It can be framed by it. The emptiness defines the stage. Our story is one of countless stories playing out on the luminous filaments within it. That perspective offers a kind of cosmic solace. The universe isn't chaotic. It's structured, lawful, beautiful in its balance. Our ability to map it, to understand the necessity of its silent chambers, is a remarkable event within it. So the void completes the human story of discovery. It's the essential backdrop against which all light, all life, all understanding finds its contrast and its meaning. We're not just in the universe, we are of it, shaped by the same elegant principles that require both something and nothing. And in that realization, the great silence becomes not a void to fear, but a space for reverence. The silence between the stars isn't a void in the story. It's the foundation of the story, and our journey through these cosmic deserts shows us something. It flips our intuition. The vast empty regions, they're not blank spaces. They're not cosmic mistakes. They're active, they're dynamic, they're essential. They're components in the universe's architecture, as vital as the galaxies themselves, sculpted by gravity's patient hand, driven by the mysterious push of dark energy. And encoded with the faintest whispers from the Big Bang, this emptiness is a participant. It shapes galaxies. It determines whether they blaze with youth or fade into quiet relics. It carves out the stable, suburban neighborhoods, like our own, where solar systems can form and life can slowly emerge over billions of years of quiet. These voids aren't just places, they're tools. They're the ultimate calibration rulers for measuring the expansion of space, the strength of dark energy, the very geometry of reality. They're mirrors for our deepest philosophical questions about existence, about meaning, about our place in a cosmos so vast that most of it is defined by absence. The universe's design is a masterpiece of balance, a breathtaking equilibrium between something and nothing. The luminous web of galaxies, with all its brilliance and activity, it's only possible because of the silent, structuring force of the voids. They're the negative space that gives the positive its form, the open chamber that gives the symphony its resonance. So when you next look up at the night sky, remember this. The darkness between the stars isn't empty, it's full of purpose. It's a necessary part of the grand cosmic symphony, written into the score from the very first